Essentials of Geometry, Day 3. This is warm-up number 8. Number 1 says, find the coordinates of the midpoint of the segment with the given endpoints. J is -7, -5, and K is -3, 7. So first thing we need to do is remember our midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Using this formula, we'd plug in our x and y values, and for x we would get -7 plus -3 divided by 2, and for y we would get -5 plus 7 divided by 2, and your answer should be -5, 1. For number 2, the endpoints of a segment are given. Find the coordinates of the midpoint, then use the distance formula to find the length of the segment. So first, again, we're going to find midpoint using our midpoint formula. 1 plus 5 divided by 2 is our x midpoint, and 4 plus 1 divided by 2 is our y point, which gives us 3 and 5 over 2. Then to find distance, we use our distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. When we plug in our values, we get 1 minus 5 squared plus 4 minus 1 squared. 1 minus 5 is -4 squared. 4 minus 1 is 3 squared, which gives us 16 plus 9, the square root of 25, which gives us 5. Last question on the warm-up. The midpoint of BC is M, which is -2, 7, and one endpoint is B at 4, 3. Find the coordinates of endpoint C. So how we do this is, since we only know one endpoint in the midpoint, we set it up with the endpoint that we know plus x2, since that's what we're looking for, divided by 2, and it equals our midpoint x value. Now to solve for x, we multiply 2 on both sides, and we get 4 plus x2 equals -4, and then we subtract 4 on both sides, and you should get x2 equals -8. Now we'll do the same thing for y. 3 plus y2 divided by 2 equals 7. Multiply 2 on both sides, we end up with 3 plus y2 equals 14. Subtract 3 on both sides, and we get y equals 11. So your final answer, the coordinates of the endpoint C, are -8, 11.
Today we're going to be talking about measuring and classifying angles and angle pair relationships. So angle names, for example, this angle to the left can be called angle A. It could be called angle CAB, or it could be called angle BAC. Notice each time the A has to be in the middle because A is our vertex. The sides of this angle, and notice they're both rays, are going to be ray AB and ray AC. So in this picture here we have 3 different angles. Let's see if we can name them. The first one is angle HGI, which is this angle. The second one we have is angle JGI, which is this angle on the bottom. But then there's a larger angle there, and that is angle HGJ. Again, the vertex is always listed in the center. We can't just say angle G here because there are 3 different angles. We wouldn't know which one we're talking about. There are several different types of angles we're going to have. One is an acute angle. An acute angle has a measure that is less than 90 degrees. It looks something like this. A right angle has a measure of exactly 90 degrees. A right angle looks like this and is usually indicated by a box drawn at the vertex. An obtuse angle has a measure that is greater than 90 but less than 180 degrees. And an obtuse angle might look like this. And last but not least is a straight angle. A straight angle measures exactly 180 degrees and may look like a line. The angle addition postulate. The angle addition postulate, similar to the segment addition postulate, tells us that we can take pieces of angles and add them to equal a bigger angle. In this example, angle RST is equal to angle RSP plus angle PST. The two smaller angles add up to the bigger angle. Here's an example of that. Given that angle CDE equals 140 degrees, we want to find the measure of angle CDF and the measure of angle FDE. Based on angle addition postulate, we know that 4x minus 8 plus 5x plus 13 is going to equal 140 degrees. If I combine like terms, I have 9x plus 5 equals 140. I'll subtract 5 from both sides, which gives me 9x equals 135. Therefore, x equals 15. Finding out x is great, but the question asks us to find the measure of those other two angles, so we need to plug back in. So the measure of angle CDF is 4 times 15 minus 8, or 52 degrees. And the measure of angle FDE is 5 times 15 plus 33, which is 88 degrees. And to check, 52 plus 88 does in fact equal the 140 degrees that we're looking for.
An angle bisector is a ray that divides an angle into two congruent angles. Let's look at example 3. In the diagram, SP bisects RST. What that means is SP, this ray right here, splits RST, the bigger angle, into two equal angles. So if RSP is 19 degrees, that means that PST is also going to be 19 degrees. The question asks us to find RST, so we simply use angle addition postulate. 19 plus 19 equals 38 degrees. Two angles are complementary if their sum of the measures is 90 degrees. So if we add two angles together and they equal 90 degrees, those two are going to be called complementary. Two angles are supplementary if the sum of their measures is 180 degrees. Same thing, if we add the two angles together and they equal 180, they're going to be supplementary. Two angles are adjacent if they share a common vertex and side but have no common interior point. Example 4, given that angle 1 is a complement of angle 2 and angle 1 equals 64 degrees, find angle 2. So what that means is angle 1 plus angle 2 is going to equal 90 degrees. Therefore, if angle 2 plus 64 equals 90, we can subtract 64 from both sides and find that angle 2 equals 26 degrees. Given that angle 3 is a supplement of angle 4 and angle 4 is 28, find the measure of angle 3. Same thing, except for this time instead of equaling it to 90, it's going to be equal to 180. So this time angle 3 plus 28 equals 180. We subtract 28 from both sides and we get angle 3 is equal to 152 degrees. Given that ABC and CBD are supplementary, find the value of x and the measure of each angle. So ABC and CBD add up to 180 degrees since they're supplements. So we can set this problem up with 4x plus 8 plus x plus 2 equals 180. We combine like terms, we get 5x plus 10 equals 180, 5x equals 170, and that leads us to x equals 4. But again, it doesn't ask us to find x, it asks us to find the measure of each angle. So when we plug x back in, 4 times 34 plus 8, so ABC is going to be 144, while CBD or DBC is going to be 36. Two adjacent angles are a linear pair if they form a 180 degree angle, In other words, a straight line. The angles are also supplementary. Two angles are vertical angles if their sides form two linear pairs. Vertical angles are always congruent. So you should be able to do the last one on your own. Good luck.